it inside a hiking backpack. Now imagine that same motor producing an unbelievable 800 horsepower. Imagine a motor so small that you could carry it inside a hiking backpack. Now imagine that same motor producing an unbelievable power than a Lamborghini Huracan's entire 10-cylinder engine. Yet this motor weighs W did not simply ignore it. They paid attention. Because this technology challenges many of the assumptions that have guided electric vehicle development for years. And that is what makes this motor so important. It is not just about creating more power. It is about changing the way engineers think about performance, efficiency, and the future of electric vehicles. To understand the dark matter motor, we first need to understand the person behind it, Christian von Koenigsegg. You cannot fully appreciate this invention without understanding the mindset of the man who created it. Christian's journey does not follow the traditional path of someone trying to build the world's most advanced hypercars. Born in Sweden, Christian developed a fascination with machines from a very young age. While other children played with toys, Christian was interested in taking things apart and understanding how they worked. He was not destroying them. He was studying them. He wanted to know why every component existed, why engineers made certain choices, and whether those choices could be improved. That kind of curiosity does not disappear with age. It grows stronger. By the time Christian was only 5 years old, he was already telling people that he wanted to build the fastest car in the world. To most people, it sounded like a childhood dream. But Christian was different. He was not simply imagining it. He was already thinking about how to make it happen. He did not come from a family with a massive automotive empire, or a fortune waiting to fund his ambitions. There was no inherited factory, no famous racing legacy, and no established path to success. Instead, he built his own businesses, slowly created the resources he needed, and in 1994 founded Koenigsegg with one clear philosophy: create something that has never been done before. For Christian, innovation is not just a marketing strategy, it is an engineering challenge. While many manufacturers focus on improving existing designs step by step, Koenigsegg often starts from the beginning and questions everything. Traditional automotive thinking is built around decades of accepted ideas. Christian sees those ideas differently. To him, many rules are simply assumptions that have not been challenged recently enough. That mindset has led to a series of groundbreaking achievements. Koenigsegg developed advanced carbon fiber monocoque structures before they became common in the industry. The company introduced the free-valve engine technology, replacing the traditional mechanical camshaft system with individually controlled valves operated through advanced electronic and pneumatic systems. This removed one of the most complex and limiting parts of conventional engine design, allowing greater control, efficiency, and performance. Then there was Koenigsegg's direct drive system, which removed the traditional gearbox from certain vehicles and connected the electric motor directly to the wheels. By eliminating the transmission, Koenigsegg reduced mechanical losses, simplified the drivetrain, and created an almost instant response between the driver's input and the car's acceleration. Many of these ideas were considered unrealistic by the automotive industry. The free-valve system was viewed by many manufacturers as too complicated and too difficult to make reliable in a production vehicle. Koenigsegg proved otherwise through extensive testing and real-world development. The direct drive system faced similar skepticism. Engineers who had spent decades designing vehicles around traditional gearboxes believed such a system would have major limitations. But Koenigsegg demonstrated what happens when you remove an entire layer of complexity instead of simply improving it. This same philosophy is what led to the creation of the dark matter motor, a machine designed not by following existing rules, but by questioning whether those rules were ever necessary in the first place. Every time Koenigsegg introduced a breakthrough, the automotive industry slowly started paying closer attention to what was coming out of that small factory in Ängelholm, Sweden. And a pattern began to emerge. The technologies that Koenigsegg proved were possible often became ideas that the wider industry explored and adopted years later. The dark matter motor is the latest and perhaps the most significant example of this approach. But to understand why this motor is such a major achievement, we first need to understand the problem it was designed to solve. Almost every electric motor used in production vehicles today is based on one of two fundamental designs. The first is the radial flux motor, which is the most common type found in electric vehicles, including Tesla models and many other mass-produced EVs. In a radial flux motor, the magnetic force that creates rotation moves outward from the center of the motor. The rotor spins inside the stator, creating movement through electromagnetic interaction. This design is effective, reliable, and well understood. However, its shape creates certain limitations. Radial motors are usually longer compared to their diameter, and their torque density, meaning the amount of torque produced relative to the motor's size and weight, is limited by the way the magnetic forces are arranged. The second major design is the axial flux motor. Instead of the magnetic force moving outward from the center, axial flux motors direct the magnetic field parallel to the motor's rotating axis. This allows the motor to be flatter and more compact while producing impressive torque for its size. In theory, axial flux designs can achieve much higher torque density than traditional radial motors. However, they also introduce difficult engineering challenges. Managing heat becomes much more complicated, and maintaining extremely precise air gaps between components is critical. Even tiny variations can reduce magnetic efficiency and performance, especially when the motor is operating under extreme conditions. Koenigsegg studied both approaches in detail. The engineering team analyzed the strengths and weaknesses of radial and axial motors and came to a surprising conclusion. Neither design alone was enough for what they wanted the dark matter motor to achieve. So instead of choosing one technology, they created something entirely different. Working from Koenigsegg's facility in Ängelholm, the engineers spent years developing a motor concept that had never been successfully applied in an automotive production environment. The challenge was not just theoretical physics. The real difficulty was manufacturing. Creating a 6-phase electric motor capable of operating reliably under automotive conditions required solving complex problems involving precision manufacturing, temperature control, vibration resistance, and extremely tight production tolerances. The fact that Koenigsegg achieved this with a much smaller engineering team compared with major global automakers highlights the company's unique approach. Rather than being limited by existing designs and traditional industry thinking, Koenigsegg's engineers started from basic principles and asked a simple question: what is actually possible if we remove the usual limitations? The result was a new type of motor that Koenigsegg describes as a raxial flux motor, a combination of radial and axial flux technologies. Instead of relying only on one magnetic pathway, the dark matter motor uses both radial and axial magnetic forces at the same time, taking advantage of each design where it provides the greatest benefit. The result is a motor that achieves levels of power and torque density that traditional radial or axial motors cannot easily match within the same size and weight limits. The numbers are extraordinary. The dark matter motor measures only 383.3 mm in height, 381.5 mm in width, and 135.5 mm in depth. It weighs just 39 kilograms. Yet it produces 800 horsepower and 1,250 Newton-meters of torque. That means it delivers around 20 horsepower per kilogram, a figure that is more than double the power-to-weight ratio of many of the highest-performing production electric motors currently available. To put that into perspective, a high-performance Tesla Model S Plaid motor system produces impressive power, but the hardware required to deliver that output is significantly heavier. The dark matter produces 597 kilowatts of power from a package weighing only 39 kilograms. The amount of performance generated from such a small physical footprint places it in a completely different category. But the innovation does not stop with the motor's shape and magnetic design. One of the most important technologies inside the dark matter is its 6-phase electrical system. Most electric motors today use a 3-phase power system. In a 3-phase motor, electricity is delivered through 3 alternating current waves that are separated by 120 degrees. These waves work together to create the rotating magnetic field that drives the motor. The dark matter uses a much more advanced approach. Instead of one 3-phase system, it uses 2 independent 3-phase systems working together. These systems are offset by 30 degrees, creating a 6-phase motor. The practical result is that the motor receives 12 power pulses during every rotation instead of 6. This creates several advantages. The delivery of torque becomes much smoother across the entire operating range. Electrical stress on the battery and inverter is reduced, and the motor operates in a more balanced and stable way. The smoother magnetic interaction also helps reduce energy losses that create unwanted heat. In simple terms, the dark matter motor does not just create more power. It creates power in a more controlled, efficient, and advanced way than traditional electric motors. Koenigsegg has confirmed that the dark matter is currently the only automotive-grade electric motor in the world using 6-phase technology. Every production electric vehicle available today, regardless of manufacturer, price, or performance level, relies on 3-phase motor technology. The Tesla Model S Plaid uses 3-phase motors. The Rimac Nevera, which held the title of the most powerful electric hypercar before the introduction of the dark matter, also uses 3-phase motors. The Porsche Taycan Turbo GT uses 3-phase motors as well. Over the past 15 years, the electric vehicle industry has pushed 3-phase motor technology to an extremely high level. Engineers have refined these systems through countless improvements, and the results have been remarkable. But 6-phase technology is not simply a slightly upgraded version of 3-phase technology. It represents a fundamentally different approach to how electrical power is delivered and controlled inside the motor. The difference is not just about adding more components or making small efficiency improvements. It changes the way torque is produced throughout the entire operating range. A 3-phase motor can continue to be optimized, but it cannot achieve the same level of performance, torque density, and efficiency that a 6-phase system can deliver within the same size and weight limitations. The impressive performance figures of the dark matter motor are built around this 6-phase architecture. It is not a minor evolution of existing electric motor design. It is a completely different engineering approach that allows Koenigsegg to achieve results that traditional motor designs cannot match. But the motor itself is only one part of the system. The component controlling all of this technology is the inverter, which Koenigsegg calls David. The name is intentional because the David inverter, combined with the raxial flux motor, is what allows the entire system to perform at its full potential. An inverter's job is to convert the battery's direct current electricity into the alternating current needed by the motor. It also controls the exact timing, power flow, and sequence of electrical energy delivery, which determines how quickly and accurately the motor responds to driver commands. With a 6-phase motor operating at 850 volts, the inverter becomes far more complex and important compared with a traditional 3-phase electric vehicle system. The David inverter was developed specifically for the dark matter motor. It was not adapted from an existing design. Every part of its control software and electrical management system was optimized around the unique characteristics of the raxial flux architecture. The result is an almost immediate throttle response, instant torque delivery from 0 RPM, and reduced heat generation compared with a system that is not perfectly matched to the motor. When the David inverter and dark matter motor work together inside the Koenigsegg Gemera, the front axle receives 800 horsepower, with a level of responsiveness that traditional mechanical or hydraulic drivetrain systems cannot replicate. However, producing massive power is only part of the challenge. The real test for any high-performance electric motor is whether it can maintain that power over time. Heat management is what separates motors that can deliver impressive numbers for a few seconds from motors that can continue performing during extended high-performance driving. Electric motors generate heat from several different sources. The first is copper loss. This happens when electrical resistance inside the motor windings converts some of the energy into heat instead of useful mechanical power. The second is iron loss. As magnetic fields rapidly change inside the motor, they create small electrical currents within the metal components, generating additional heat. The third source comes from mechanical losses, including friction from bearings and seals. Managing all of these heat sources simultaneously while producing 800 horsepower from a motor weighing only 39 kilograms requires an extremely advanced cooling system. Koenigsegg designed the dark matter with an integrated liquid cooling system built directly into the motor structure. Coolant channels are positioned close to the components most vulnerable to heat buildup, allowing temperatures to be controlled more effectively. Combined with the efficiency improvements created by the 6-phase system and the precision control of the David inverter, the dark matter can maintain high output for much longer than a conventional electric motor with similar peak power. In practical terms, this means the Koenigsegg Gemera is not limited to a single burst of acceleration. It can deliver its full front axle power during extended performance driving, whether that means repeated acceleration runs, track sessions, or demanding high-speed driving. This difference between peak performance and sustained performance is one of the most important factors in electric motor technology, and one of the least discussed. A motor that produces 800 horsepower for only 3 seconds before reducing power to prevent overheating is very different from a motor that can maintain 800 horsepower for as long as the driver continues to demand it. True performance is not just about reaching a huge number, it is about being able to use that number repeatedly, consistently, and reliably. The dark matter motor is designed to be the second type, a system capable of delivering extreme power while maintaining that performance over extended periods. The thermal management system that makes this possible is just as carefully engineered as the Raxial flux architecture itself. Koenigsegg has not published specific duty cycle data that would allow independent verification of exactly how long the motor can sustain peak output. However, the company's history of delivering on its published engineering claims gives these statements more credibility than similar announcements from manufacturers with less experience proving ambitious performance targets. This leads to the question the entire electric vehicle industry is watching closely. Is the dark matter a serious challenge to Tesla and other major EV manufacturers? The answer is yes, but not in the way many people might expect. The dark matter is not a threat because Koenigsegg plans to produce millions of these motors or compete directly with mainstream electric car manufacturers. Koenigsegg builds fewer than 100 vehicles per year. The dark matter motor inside the Gemera is an ultra-low volume technology and will not become a mass-market product anytime soon. The real impact of this technology is much bigger than sales numbers. The threat is the proof that it provides. For years, the electric vehicle industry has treated certain limits in power density and torque output as if they were unavoidable laws of physics. The dark matter challenges that assumption. It demonstrates that these limitations are not permanent barriers. They are engineering challenges that have simply not been solved by the companies working on them so far. When a company with around 80 employees in Sweden creates an electric motor capable of producing 800 horsepower from just 39 kilograms using a 6-phase Raxial flux design, it forces the largest automotive companies in the world to ask an uncomfortable question. If a small engineering team can achieve this, why can't we? And that question does not disappear. It becomes more important every year. The dark matter continues to perform as promised in customer-owned Gemeras, on public roads, and through technical analysis followed closely by engineering teams around the world. The history of automotive innovation is filled with examples of technologies that started with small specialist manufacturers before eventually influencing the entire industry. Carbon fiber monocoque structures were first developed in racing and high-end supercars before becoming more common in production vehicles. Ceramic brake systems moved from motorsport applications into road cars. Dual-clutch transmissions were refined through racing before becoming a major feature in performance and everyday vehicles. The Raxial flux 6-phase motor could become the next technology to follow that same path. The companies that will shape the future of electric performance will be the ones that recognize the importance of this technology early before repeated real-world testing removes any remaining doubts. But before reaching the final conclusion, it is important to look at the vehicle that brings all of this technology together, the Koenigsegg Gemera. The motor is revolutionary, but the car itself is an equally important achievement. The Gemera is the first 4-seat vehicle ever created by Koenigsegg. It is also the first production car to truly combine the practicality of a 4-seat grand touring vehicle with the performance capabilities of an extreme hypercar. Other manufacturers have attempted to create powerful family-oriented performance cars, but Koenigsegg approached the idea differently. The goal was not to compromise between comfort and speed. It was to deliver both without sacrificing either. The Gemera measures 4,975 mm in length, provides comfortable seating for 4 adults, and offers enough space for 4 carry-on suitcases. Yet, despite its practicality, it delivers performance numbers that rival the fastest vehicles on Earth. It can accelerate from 0 to 100 km per hour in just 1.9 seconds and has a top speed rated by Koenigsegg at over 320 km per hour. The original Gemera concept revealed in 2020 featured a different powertrain configuration. The production version, which began reaching customers in 2025, introduced an even more advanced setup. At the rear sits a 5.0-litre twin-turbocharged hot V8 engine, while the front axle is powered by the dark matter electric motor. Together, the system produces an incredible 2,300 horsepower and 2,750 Nm of torque, making the Gemera one of the most powerful, fully homologated production cars ever created. Even the transmission system is a technological achievement. The light-speed tourbillon transmission, which manages power delivery between the V8 engine and the electric motor, is advanced enough that it could be the headline feature of another vehicle. But in the Gemera, it is just one part of a much larger engineering story. The Gemera represents Koenigsegg's complete vision, a vehicle that combines luxury, practicality, extreme performance, and groundbreaking technology into a single package. It is not just a hypercar. It is a demonstration of what becomes possible when engineers refuse to accept existing limits. The Koenigsegg Gemera represents something the automotive world has never truly seen before. It is a 4-seat car that Koenigsegg describes as the world's first Mega GT, a vehicle that combines everyday usability with the performance of an extreme hypercar. The Gemera produces an incredible 2,300 horsepower through the combination of its rear-mounted twin-turbo V8 engine and the single dark matter electric motor powering the front axle. It can accelerate from 0 to 100 km per hour in just 1.9 seconds, while still offering seating for 4 adults, a comfortable interior, practical luggage space, and a claimed driving range of more than 900 miles when combining electric and combustion power. Only 70 units of the Gemera will be produced. Every single one has already been sold. But the buyers are not simply purchasing another hypercar. They are buying a snapshot of the most advanced automotive engineering available in the world today, and at the heart of that engineering is a 39-kilogram electric motor that so far no other manufacturer has been able to reproduce. One of the biggest questions surrounding the dark matter motor is whether technology this advanced can ever move beyond a limited production hypercar. At first glance, it seems like a component that would cost an enormous amount to manufacture, something reserved only for vehicles costing millions of dollars. However, Koenigsegg has stated that its goal is not to keep this technology exclusive forever. The company has expressed interest in making the motor technology available to other manufacturers. Koenigsegg already works with external partners and has built its business around maintaining control over advanced engineering while allowing its innovations to create wider impact. As production methods improve and manufacturing processes become more efficient, the cost of producing this type of technology will naturally decrease. That is the same pattern followed by almost every major technological breakthrough. The dark matter motor in 2025 is similar to where the original iPhone was in 2007. It is a revolutionary piece of technology, incredibly powerful and compact, but currently available only to a very small group of people. The first iPhone did not immediately replace every other mobile phone. It took years for the technology to improve, production costs to decrease, and the features to become accessible to a much larger audience. But the moment Apple demonstrated what the iPhone could do, the direction of the entire smartphone industry changed. No major phone manufacturer believed the world would return to traditional physical keyboards as the dominant design. The dark matter represents a similar moment for electric motor technology. It shows what could be possible in the future